Friends, welcome back to Engineering Mathematics 4. I think in the last session we have discussed about special functions and I have solved some preliminary examples. So for example, I have considered a differential equation of the type dy by dx plus xy is equal to 0. So it means we are already familiar with a linear differential equation with constant coefficients, and yesterday we have discussed about a linear differential equation with variable coefficients. How do we find out the solution? And as we know that the coefficient of dy by dx or d square y upon dx square all are variable or polynomials. Right. So when x is equal to 0 is an ordinary point, or when x is equal to 0 is an regular singular point. Right. So we want to assume the solution in the form of a series. Right. So and then we want to find out the values of a0, a1, a2, a3 and so on. Then you can substitute all the values in the assumed solution, coefficient of a0 and coefficient of a1. So it means series solution can be expressed in terms of a0 and a1, where a0 and a1 are arbitrary constants. So we have discussed all these things in the last period. Now I want to continue exactly in the similar way. We can discuss about Frobenius method. Right. So now you are observing the given equation may be in this form: p0 x into d square y upon dx square plus p1 x into dy by dx plus p2 x into y is equal to 0. Again here p0, p1, p2 are polynomials. Right. So here x is equal to 0 is a regular singular point. Right. So in that case we can assume a series solution in the form of y is equal to x to the power m into a0 plus a1x plus a2x square into plus a3 into x to the power 3 and so on, plus an into x to the power n and so on. Or you can write down in the form of summation ak into x to the power m plus k, where k varies from 0 to infinity. Right. So this becomes the solution of the given differential equation. Now I am going to differentiate this equation. It means I can differentiate the assumed solution. So therefore dy by dx is equal to, so I will get summation of m plus k into ak x to the power m plus k minus 1. So how we are going to differentiate? So in terms of summation, ak is constant, you can keep as it is. By using the formula x raised to n, we can differentiate. So you will get m plus k into x to the power m plus k minus 1. Okay. Now I want to obtain second derivative, because the given equation containing second derivative. So that's why you will get d square y upon dx square is equal to summation of m plus k is constant, ak is constant and x to the power m plus k plus minus 1. So you can keep as it is into x to the power m plus k minus 2. Again by using the formula x raised to n, derivative of x raised to n is n into x raised to n minus 1. I hope we will get a second derivative. Now I want to substitute the value of d square y upon dx square, dy by dx and y in equation 1. I will get the equation. Then I want to collect, equate to 0 the coefficient of lowest power of x, as we have done in the last session. So now from all the terms I want to collect the various powers of x. First I am going to collect the lowest power of x and I will equate it to 0. This gives a quadratic equation in M, which is known as indicial equation. Then equated to 0 the coefficients of other powers of x to find a1, a2, a3 and so on, as we have discussed in the last period. As I have mentioned, we want to find out the recurrence relation. From the recurrence relation you can obtain various values. You want to replace n by 2, 3, 4, 5 and so on, then you will get various constants. Then we want to substitute the values of a1, a2, a3 and so on in the assumed solution to get the series solution of a given equation. Since the complete solution must have two independent arbitrary constants, the method of a complete solution depends upon nature of roots of the indicial equation. So it means you will get an indicial equation depending upon the solution of initial equation, we are able to write down the solution. So it means as we know, suppose if the given equation is an linear differential equation with constant coefficients, say for example they have given second order differential equation, you will get an auxiliary equation, you will find out the roots, depending upon the roots or nature of the roots, we are able to write down the complementary function. Exactly in the similar way, here also we will get an initial equation, we want to find out the roots, so depending upon the roots we are able to find out solutions, right. So that's why we can go for case by case. When the roots m1 and m2 of the initial equation are distinct and not differing by an integer, so in that case what is the complete solution of the given differential equation? So you can write down in this form, y is equal to c1 y suffix m1 plus c2 y suffix m2, right. So here c1 and c2 are the arbitrary constants. So exactly in the similar way, when the roots m1 and m2 of the initial equation are equal, means m1 is equal to m2. So in that case the complete solution is c1 y suffix m1 c2 partial derivative of y with respect to m suffix m1. It means if m1 is equal to m2, then you will get the solution of the given differential equation in this form. Okay. When the roots m1 and m2, m1 may be less than m2 of the initial equation are distinct and differ by an integer. So in that case, let sum of the coefficients of y series become infinite when m is equal to m1. It means smaller of the two roots. In that case, I want to replace a naught by b naught into m minus m1 in the series for y. So complete solution becomes y is equal to c1 into y suffix m1 plus c2 into partial derivative of y with respect to m into suffix m1. So like that we can write down the solution. The solution corresponding to m is equal to m2, it means greater of the two roots. So is a constant multiple of the solution corresponding to m is equal to m1, right. So first you want to obtain the initial equation, find out the roots, according to the roots we want to write down the complete solution. So now I want to solve one such type of example. So it is given that 2x square into d square y upon dx square plus 2x square minus x into dy by dx plus y is equal to 0. So clearly this is the given differential equation. Now you want to verify whether x is equal to 0 is a regular singular point or not. The coefficient of d square y upon dx square is 2x square. When we replace x by 0, it becomes an 0. So it means x is equal to 0 is a regular singular point. Then I can assume the solution of given differential equation is y is equal to x to the power m into the bracket a naught plus a1x plus a2x square and so on. What is the nth term? An into x to the power n. Or you can write down in the form of summation of ak into x to the power m plus k. K varies from 0 to infinity. So now I want to find out the derivative. So dy by dx can be written as a summation of k varies from 0 to infinity m plus k ak x to the power m plus k minus 1. Again by using the formula x raised to n, you can differentiate. I hope you will get this equation, right. So exactly in the similar way you want to obtain second derivative. Summation of m plus k is constant, ak is constant, you can keep as it is x raised to m plus k minus 1, again by using the formula x raised to n. So you will get m plus k minus 1 ak x to the power m plus k minus 2. So now I will substitute the value of y, the value of dy by dx, the value of d square y upon dx square in the given equation. I can obtain 2x square into d square y upon dx square. So what is the value of d square y upon dx square? So this is the value of d square y upon dx square. You can substitute plus 2x square minus x into dy by dx. So you know the value of dy by dx just now we have obtained. So it can be written as summation of m plus k ak x to the power m plus k minus 1 plus the value of y, assumed solution, summation of ak x to the power m plus k is equal to 0, right. So now in all the terms I want to replace k by 0, k by 1 and so on, right. So 2x square into the value of d square y upon dx square plus 2x square minus x into dy by dx plus y is equal to 0. So when we replace k by 0 in this equation, so what you will get? So m plus k means m into m minus 1, right, into a naught x to the power m plus k minus 2 means I am replacing k by 0. I hope you will get x to the power m minus 2. And similarly, plus I want to replace k by 1. So you will get m plus 1 minus 1 means m into a1 x to the power m minus 1, because the value of k is 1. X to the power m plus 1 minus 2 means you will get x to the power m minus 1. Plus next I want to replace k by 2. So you will get m plus 2 and m plus 1 into a2 x to the power m, right. Plus next I want to replace k by 3. You will get m plus 3 m plus 2 a3 x to the power m minus 1 and so on. So like that you will get various terms from the first summation. Now exactly in the similar way, plus you want to write 2x square minus x as it is, right. So into summation of this term, again you can replace k by 0. So what you will get? M plus k means m plus 0, it can be written as m. So a suffix k, you can replace k by 0, a naught into x to the power m plus k minus 1 means m minus 1, what I have written here, right. So now I will replace k by 1. So you will get m plus 1 a1 x to the power 1. If you replace k by 2, you can obtain m plus 2 a2 x to the power m plus 1 and so on, right. So finally, what is the last term? The value of y, summation of ak x to the power m plus k. In this also I am going to replace k by 0. So I can obtain a naught into x to the power m plus a1 into x to the power m plus 1 when I replace k by 1. When I replace k by 2, I can obtain a2 x to the power m plus 2 and so on is equal to 0, right. So from all these terms, now I want to collect the lowest power of x. So what is the lowest power of x in all these terms? X to the power m. Now I want to equate it to 0, right. So can you tell me what is the lowest power of x? I have to multiply 2x square into x to the power m minus 2, right. So x to the power 2 x to the power m minus 2, it means base is same, you can add the powers. So I hope you will get x to the power m minus 2 plus 2 means x to the power m. The coefficient of x to the power m is m into m minus 1 a naught. So what I have written here, 2 into m minus 1 a naught, right. So next I can multiply x square into x to the power m minus 1. I will not get x to the power m. I will ignore all these terms, right. So like that you can collect the coefficient of x to the power m. I hope we will get minus times of m into a naught plus a naught, right. In the last series you can observe the coefficient of x to the power m is a naught, right. Now here also you can multiply x square into x to the power m minus 1. It means x to the power m plus 2 minus 1 you will not get, right. So you will get all the coefficients of x to the power m in this form, right. So now you can simplify. So a naught is common, you can take out, a remaining thing can be written as 2m square minus 3m plus 1 into a naught is equal to 0, right. Or it can be written as 2m minus 1 into m minus 1 is equal to 0. So because a naught is not equal to 0, right. So it is of the type a into b is equal to 0. Either a is equal to 0 or b is equal to 0. It means 2m minus 1 is equal to 0 or m minus 1 is equal to 0, right. So I want to find out the values of m. So I can obtain m is equal to 1 by 2. 2m minus 1 is equal to 0. Therefore 2m is equal to 1. Therefore m is equal to 1 by 2. So m minus 1 is equal to 0. It means m is equal to 1. So it means we have obtained the roots of initial equation. So what are the roots? 1 by 2 comma 1. Okay, so now I have equated the lowest power of x. What is the lowest power of x? X to the power m. Now exactly in the similar way, now I want to equate it to 0 the coefficient of its next power. Its next power means x to the power m plus 1. So from this equation I have to identify what are the coefficients of x to the power m plus 1, and I want to equate it to 0. I hope you will get all these terms. All these terms are coefficients of x to the power m plus 1. Now first one is 2m into m plus 1 a1 plus 2m a0 minus m plus 1 into a1 plus a1 is equal to 0, right. So a1 is common, you can take out 2m square plus m into a1 plus 2m into a0 is equal to 0, or further you can simplify. So m is common, m into 2m plus 1 a1 plus 2 times of a0 is equal to 0, or the same equation can be written down in this form: 2m plus 1 into a1 plus 2 times of a0 is equal to 0. Since m is not equal to 0, because just now we have obtained m is equal to 1 by 2 and 1. So you will get a1 is equal to minus times of 2 divided by 2m plus 1 into a0. Okay. Now exactly in the similar way, now I want to equate it to the coefficients of x to the power m plus 2. So you can collect all these terms from the previous equation. What are the coefficients? 2 times of m plus 2 into m plus 1 into a2 plus 2 times of m plus 1 a1 minus m plus 2 a2 plus a2 is equal to 0, right. So you can collect a2, a2 is common, so you will get 2m square plus 5 times of m plus 3 plus 2 times of m plus 1 into a1 is equal to 0, or you can factorization. By using the factorization method, you can obtain 2m plus 3 into m plus 1 a2 plus 2 times of m plus 1 a1 is equal to 0. Is it clear? Or the same thing can be written in this form: 2m plus 3 into m plus 1 a2 plus 2 times of m plus 1 into a1 is equal to 0, right. So or it can be written in this form: 2m plus 3, m plus 1 is common, right. So you can take out, remaining thing can be written in this form, right. Or the same thing can be written as 2m plus 3 into a2 plus 2 times of a1 is equal to 0. So because m plus 1 is not equal to 0. Okay. So from this equation you can obtain the value of a2. So a2 is equal to, you can obtain minus times of 2 divided by 2m plus 3 into a1, right. So we are already familiar with the value of a1. You can substitute the value of a1, simplify. I hope you will get minus 4 divided by 2m plus 1 into 2m plus 3 into a0. Okay. Exactly in the similar way, now I want to collect the coefficients of x to the power m plus 3. So you will get 2 times of m plus 3 into m plus 2 a3 plus 2 times of m plus 2 a2 minus m plus 3 a3 plus a3 is equal to 0. So you can simplify. I hope you can obtain 2m2 plus 9m plus 10. When you multiply these two factors and a3 is common, you can write down plus 2 times of m plus 2 a2 is equal to 0, right. Or again you can write down in this form. So or the same thing can be written as 2m plus 5 into a3 plus 2 a2 is equal to 0, because m plus 2 is not equal to 0. So from this you can write down the value of a3. a3 is equal to, or 2m plus 5 plus a3 is equal to minus times of 2 times of a2. Then you can divide by 2m plus 5. I hope you can obtain the value of a3 in terms of a2. But a2 is also known. You can substitute the value of a2. Finally, you will get a3 in terms of a0, and so on. Exactly in the similar way, we can collect what are the coefficients of x to the power m plus 4, m plus 5, and so on. Right. So in all these cases, you know the value of m. You want to substitute the value of m. So for example, we have obtained the value of m. What are the value of m? 1 by 2 comma 1. First I want to replace m by 1 by 2 and I can obtain the value of a1. So what is the value of a1? So a1 is minus times of 2 divided by 2m plus 1 into a1. So what is the value of m? M is 1 by 2. So it means minus 2 divided by 2 into 1 by 2 means it is 1. 1 plus 1 is 2. Numerator is 2, denominator is 2. So it means 2 cancels with 2. I hope I can obtain the value of a1 is minus times of a0, right? So what I have written here, a1 is equal to minus times of a2. Similarly, you know the value of a2. I have written a2 in terms of a0. So here I can replace m by 1 divided by 2. So 2 by 2 means it is 1. 1 plus 1 is 2, right? Again 2 by 2 is 1. 1 plus 3 is 4. 4 into 2 is 8. So 4 divided by 8 means 1 by 2. I hope you will get minus times of 1 by 2 a0, right? So again a3 is known. In this case you can replace m by 1 by 2. 2 into 1 by 2. 2 by 2 means it is 1. 1 plus 1 is 2, right? So again m is 1 by 2. 2 by 2 is 1. 1 plus 3 is 4. 4 into 2 is 8. Numerator is denominator 8 cancels, right? So again we can replace m by 1 by 2. 2 by 2, 1. 1 plus 5, 6. So it means you will get minus times of 1 by 6 into a0. So that is the value of a3, what I have written here. Exactly in the similar value you can calculate some more values, then you can substitute all these values in the solution, assumed solution. So y1 is equal to, I want to collect a0 is common in all the terms, I will take out a0, x to the power m. M means 1 by 2 into the bracket 1 minus x plus x square by 2 minus x cube by 6 and so on, right? So this becomes one solution of the given differential equation. Exactly in the similar way we can find out the second independent solution. Y2 is equal to a0 into x to the power m. It means in all those cases I want to replace m by 1. So that's why I have written x to the power m means here m is equal to 1. That's why you will get x into the bracket 1 minus 2 by 3x plus 2 square x square 2 square x square divided by 3 into 5 minus 2 to the power 3 x cube divided by 3 into 5 into 7 and so on, right? Then what is the complete solution of the given differential equation? The complete solution of the given differential equation is y is equal to c1 y1 plus c2 y2 is the complete solution of the given equation. Friends, exactly in the similar way you can practice some more examples, right? So here I wanted to give 1 or 2 examples as a homework. So it is given that x into d square y upon dx square plus dy by dx minus y is equal to 0, right? So here also x is equal to 0 is an regular singular point because this becomes 0. That's why you can assume the solution of this equation is y is equal to x to the power m, right? So into the bracket a0 plus a1 into x, a2 into x square and so on. Then you can find out all the constants, then you can substitute, you will get the solution, right? So before that you want to calculate what are the roots of the initial equation, right? I hope in this case, so you will get plus or minus 2 are the roots of the initial equation. According to these two numbers, you are able to write down 2 independent solutions and a complete solution of this equation, right? So exactly in the similar way you can find out the solution of another equation, say x into d square y upon dx square plus dy by dx plus x into y is equal to 0. Again you can observe x is equal to 0 is a regular singular point. So once again you can assume the solution of this equation is of the form y is equal to x raised to m into the bracket a0 plus a1x and so on, right? Again you want to calculate the constants, then replace m by 0. Observe m is equal to 0 and 0 are the roots, repeated roots. I hope you are able to write down the complete solution of this equation. Or sometimes the given equation may be like this, x into 1 minus x into d square y upon dx square minus 1 plus 3x into dy by dx minus y is equal to 0, right. Here also it is a regular singular point. Here also you will get an indicial equation. Find out the roots. What are the roots? I hope you will get 0, 2 are the roots of this equation, right. So find out the solution and write down the complete solution of the given differential equation. Okay. Now so far we have solved some differential equations. Those differential equations help us to find out the solution of Bessel's equation. Okay. So before calculating the solution of the Bessel's equation, now I wanted to give the definition of Bessel differential equation, right. So what is the Bessel's differential equation? The second order differential equation given as x square into d square y upon dx square plus x into dy by dx plus x square minus n square into y is equal to 0. So this equation we call it as an Bessel's equation, or I can say that is known as Bessel's equation, where the solution of Bessel's equation yields Bessel's functions of the first kind and second kind as follows. So we are able to write down the solution of this equation in this form: y is equal to a into jnx plus b into y suffix nx, where a and b are arbitrary constants, right. So Bessel function means first kind. So jnx is the solution to Bessel's equation, is referred as Bessel's function of the first kind. It means the coefficient of a is called Bessel's function of a first kind, and similarly, so this we call it as an Bessel's function of a second kind, or sometimes we may call it as an Weber function or Neumann function. Is it clear, right? So we want to find out the solution of this equation. The complete solution of this equation can be written down in this form. So these two, ynx and jnx, are called Bessel's functions. Okay. So given equation may be in this form: x square into d square y upon dx square plus x into dy by dx plus x square minus times of n square into y is equal to 0. So is often encountered when solving a boundary value problem, such as separable solutions to Laplace equation or Helmholtz equation, especially when working in cylindrical spherical coordinates, right. The constant n, so this equation containing a constant n, determines the order of the Bessel's function. So because sometimes we call it as an first order Bessel function, second order Bessel's function, zeroth order Bessel's function, right. So found in the solution of Bessel's differential equation, and can take any real number value for integer value n, while for spherical problems the order is of half integer value. So how we are going to write down n plus 1 by 2. Since Bessel's differential equation is a second order equation, there must be two linearly independent solutions. So it means the order of the given differential equation is 2, and we know that you will get two independent solutions, right. So okay, now you want to find out the solution of the Bessel's equation. So far we have discussed about how we are going to recognize Bessel's equation and what are the two independent solutions. Now we want to find out those two independent solutions, right. So this is the Bessel's equation, given that x square into d square y upon dx square plus x into dy by dx plus x square minus n square into y is equal to 0. So far we have solved many differential equations. You can treat it as another example, right, similar to previous examples, right. Here also I want to verify whether x is equal to 0 is an regular point or not, or a regular singular point or not, whether I am able to find out a series solution or not, right. So you know the coefficient of d square y upon dx square. So replace x by 0. I hope it is equal to 0, right. So therefore is a regular singular point. Then you can assume the solution of the given differential equation as y is equal to x to the power m into the bracket a naught plus a1x plus a2x square plus a3 into x to the power 3 plus a4 x to the power 4 and so on. What is the nth term? An into x to the power n, or you can write down in the form of a summation of ak into x to the power m plus k, where k varies from 0 to infinity, right. So now I want to differentiate this solution two times, because Bessel's equation containing the term dy by dx d square y upon dx square. Then I will substitute. Okay, what is the value of dy by dx? Summation of ak is constant. I will differentiate x to the power m by using the formula x raised to n. That's why you will get m plus k into x to the power m plus k minus 1. Similarly, second derivative can be obtained again by using the formula x raised to n. Summation of m plus k is constant, right. So x to the power m plus k minus 1. So n into x to the power n minus 1, m plus k minus 1 ak x to the power m plus k minus 2, right. So now I want to substitute the value of y dy by dx and d square y upon dx square in the given differential equation or in the Bessel's equation, right. I hope you will get x square into the value of d square y upon dx square, right. Simply you can replace this right hand side value plus x into the value of dy by dx, summation of m plus k ak into x to the power m plus k minus 1 plus x square minus n square into the value of y. What is the value of y? Summation of ak into x to the power m plus k is equal to 0, right. So simply I have replaced the value of d square y upon dx square plus x into the value of dy by dx plus x square minus n square into y is equal to 0. Now I want to simplify, or you can rearrange the terms, right. So here the coefficient of summation is x square. I want to multiply. So m plus k is constant. I have written as it is, right. So m plus k minus 1 is constant as it is. ak is constant as it is, right. X to the power m plus k minus 2 into x square. So base is same. You can add the powers. That's why you will get x to the power m plus k, right, plus x. Again I want to multiply x into x to the power m plus k minus 1. Remaining thing as it is. I hope you will get x to the power m plus k plus x square into, you can multiply ak x to the power m plus k, x square into I have written minus times of n square into as it is, summation of ak x to the power m plus k is equal to 0. Okay, right. So further you can rewrite it as it is m plus k minus 1 is there, no. I will split this into two terms. That's why I have written minus times of m plus k ak x to the power m plus k from the first summation plus summation of m plus k as it is ak x to the power m plus k, right. So here x square is there, right. I will multiply x square into, you will get summation of m plus k ak x to the power m plus k minus times of n square into ak x to the power m plus k, right. So x square into x to the power m plus k means again base is same. You can add the powers. I hope you will get x to the power m plus k minus 2 is equal to 0, right. So now from these terms, what are the common things? You can observe ak into x to the power m plus k is common. ak into x to the power m plus k is common, right. So write down the remaining things within the bracket. Summation of m plus k whole square minus m plus k minus n square. So I hope these two terms will cancel, right, into ak x to the power m plus k. So remaining thing is as it is, summation of ak x to the power m plus k plus 2. It means last term, right. So I hope these two terms will cancel. Remaining thing is m plus k whole square minus n square into the bracket ak x to the power m plus k plus last term as it is. You can write down is equal to 0. Like previous examples, here also you can collect the lowest power of x. So in the previous equation you want to replace So k by 0, k by 0, k by 1, k by 2, k by 3 and so on. Here also you want to replace k by 0, 1, 2, 3 and so on. You will get various terms and you want to collect the lowest power of x, and it becomes x to the power m corresponding to k is equal to 0 and equate to 0 the coefficient of x to the power m. You will get an initial equation, say m square minus n square is equal to 0 because a naught is not equal to 0. So m square minus n square is not equal to 0 means I hope you will get m is equal to plus or minus n, right. Now exactly in the similar way, now we want to collect some more terms. Some more terms means the coefficient of x to the power m plus 1. So what are the coefficients of x to the power m plus 1? So what I have written here. So within the bracket you will get m plus 1 whole square minus n square into a1 is equal to 0. So this implies a1 is equal to 0. How do you say that a1 is equal to 0? So because m plus 1 whole square minus n square into a1 is not equal to 0 for m is equal to plus or minus n, right. So equating to 0 the coefficients of x to the power m plus k minus 2. We get the recurrence relation. What is the recurrence relation? So m plus k plus 2 whole square minus n square into the bracket a suffix k plus 2 plus ak is equal to 0. So from this you can obtain the value of a suffix k plus 2. You can write down the remaining thing other side. I hope you will get. So ak times of m plus k, sorry m minus k plus 2, m plus n plus k plus 2, right. So in this recurrence relation you can replace k by 1, 3, 5 and so on. I hope you can obtain the value of a3, the value of a5, the value of a7 and so on, and I hope all these becomes 0, right. And similarly in this recurrence relation we can replace k by 0, 2, 4, 6 and so on, and I can obtain a2 is equal to a naught divided by m minus n plus 2 because when we replace k by 0. Similarly m plus n plus 0 plus 2, it means you will get m plus n plus 2, right. So when we replace k by 2 I can obtain a4 is equal to a2 divided by m minus n 2 plus 2, it means 4, m plus n plus 2 plus 2 means again it is 4, right. And you know the value of a2, right. You can substitute and you can simplify. I hope you will get in terms of a naught. So a4 is equal to a naught divided by m minus n plus 4, m plus n plus 4 into one more factor is m minus n plus 2 and last factor is m plus n plus 2 and so on. So like that I can obtain a6, a8 and so on, and we can substitute all these values in the assumed solution. I hope assumed solution becomes y is equal to a naught into x to the power m into the bracket first term becomes 1 minus times of x square divided by m plus 2 whole square minus n square plus x raised to 4 whole divided by m plus 2 whole square minus n square into the bracket m plus 4 to the power 2 minus n square and so on, right. So depending upon the value of n we get different type of solutions. I can consider when n is non-zero and when n is non-integer. So in that case what is the solution? I can take m is equal to n. So it means in this equation wherever m is there, no, I want to replace m by n. I hope I can obtain y1 is equal to a naught into x to the power m means it is n into the bracket 1 minus x square divided by, here m is there, no, I am going to replace m by n. So you will get 4 times of n plus 1 plus x square, x to the power 4 divided by 4 square 2 factorial n plus 1 into n plus 2 after simplification, right. So minus x to the power 6 whole divided by 4 to the power 3 into 3 factorial into the bracket n plus 1, n plus 2, n plus 3 and so on, right. Now exactly in the similar way if I replace m by minus times of n. I can obtain one more equation, namely 3, and I can call it as an y2 is equal to a naught x to the power minus n into the bracket 1 minus x square by 4, replace n by minus n plus 1, right, plus x to the power 4 square 2 factorial minus n plus 1 minus n plus 2 and so on. So, you may call it as an another equation, say 3. Suppose if I replace a naught by 1 divided by 2 to the power n into gamma of n plus 1, then the solution given by equation 2 is called the Bessel function of the first kind of order n and is denoted by j suffix nx. And also we know that n into gamma of n is equal to gamma of n plus 1. So, we can rewrite it as summation jnx is equal to x by 2 to the power n is common from all the terms. You can take out and into the bracket we can write down 1 divided by gamma of n plus 1 minus 1 divided by 1 factorial into gamma of n plus 2 into the bracket x by 2 to the power 2 plus 1 divided by 2 factorial into gamma of n plus 3 x by 2 to the power 4 minus 1 divided by 3 factorial gamma of n plus 4 into the bracket x by 2 to the power 6 and so on. Here n is greater than 0 and these terms can be written down using the summation. It can be written as r is equal to 0 to infinity minus 1 to the power r x by 2 to the power n plus 2r into 1 divided by r factorial into gamma of n plus r plus 1. So, you may call it as an equation number 4 corresponding to 3. So, what we have replaced m by minus n. So, you can write down equation number 3 in this form, j suffix minus nx is equal to summation of r varies from 0 to infinity minus 1 to the power r x by 2 to the power minus times of n plus 2r into 1 divided by r factorial gamma of minus n plus r plus 1, right. So, which is called Bessel function of the first kind of order minus n. Hence, the complete solution of the Bessel's equation can be written down in this form, y is equal to a into jnx plus b into j suffix minus nx, where a and b are the arbitrary constant. Okay. So, now I want to consider when n may be equal to 0, in that case what is the complete solution of the Bessel's equation. The Bessel equation takes the form from equation A. So, now you want to assume a naught is equal to 1 and you can replace n by 0 in equation 1. That can be written as y is equal to a naught into x to the power m into the bracket 1 minus x square divided by m plus 2 whole square minus n square plus x raised to 4 whole divided by m plus 2 whole square minus n square m plus 4 whole square minus n square and so on. Or you can, as I have mentioned, you can replace a naught by 1. So, I hope you will get x to the power m, right, then 1 minus x square by m plus 2 whole square and so on. You can rewrite in this form. Suppose if m is equal to 0, the first solution is given by, so jnx is equal to summation of minus 1 to the power r x by 2 to the power n plus 2r into 1 divided by r factorial gamma of n plus r plus 1, right. So, when we replace n by 0, so you will get j naught x, k varies from 0 to infinity minus 1 to the power k x by 2 to the power 2 k 1 divided by k factorial whole square. How you will get this equation? In equation number 4, put n is equal to 0, r is equal to k and gamma of k plus 1 is equal to k factorial, right. I hope you will get a Bessel function of the first kind of order 0, right. So, therefore, y is equal to x raised to m, you are able to write down in this form. Now, differentiate the above equation with respect to m. I want to differentiate this equation with respect to m, right. So, now you observe it is containing x to the power m into the bracket some terms may also contain m. How do we differentiate this equation? So now you can use the product formula to differentiate this equation, right? So if I differentiate, I hope we will get partial derivative of y with respect to m. So you know the derivative of a to the power x. By using that formula, I can differentiate x to the power m into log x, because the derivative of a raised to x is a raised to x into log a, using that formula. And I will keep second function as it is. So it means I will write these terms as it is, right? So plus, now I want to keep first function as it is. What is the first function? X to the power m. Now I want to differentiate all these terms. So first term is constant, it becomes 0. So now I want to differentiate second term with respect to m. I hope I can obtain x square divided by m plus 2 whole square into 2 divided by m plus 2. Next term is x raised to 4 whole divided by m plus 2 whole square, m plus 4 whole square. I want to differentiate with respect to m. I can obtain x raised to 4 whole divided by m plus 2 whole square, m plus 4 whole square into the bracket. After simplification, I hope you may obtain 2 divided by m plus 2 plus 2 divided by m plus 4 and so on. It means the second independent solution is given by partial derivative of y with respect to m at m is equal to 0. So how we are going to write down the complete solution of the Bessel equation of order 0 can be write down y is equal to a into j naught x plus b into y naught x. Here y naught x is called Bessel function of the second kind of order 0, or sometimes we may call it as an Newman function. Similarly, I want to consider when n is an integer, right? The two functions j suffix n and j suffix minus n are not independent but are connected by the relation. So j suffix minus nx is equal to minus 1 to the power n j n x, right? So we are already familiar with j suffix minus nx can be written down in this form. Summation of k varies from 0 to infinity minus 1 to the power k x divided by 2 to the power minus n plus 2r into 1 divided by k factorial into gamma of minus n plus k plus 1. So we know that gamma of a negative integer or 0 tends to infinity. Each term in the summation is 0 as long as minus times of n plus k plus 1 is less than or equal to 0. That is, k is less than or equal to n minus 1, right? So that is gamma of minus n plus k plus 1 is finite when k is greater than or equal to 0. So in the next session we can prove this result, left hand side is equal to right hand side. So thank you.